Hey guys, so today I'll be showing you how to do particle swarm optimization in Python in 40 minutes. So let's get started. I created a little slideshow just so you can see, just so I can kind of like show you what like particle swarm optimization is about. So yeah. Hey, before we started the video, only a small percentage of my viewers are actually subscribed. So if you're not, or if you're in the percentage that isn't, please subscribe. It would help me out a ton, and you can always unsubscribe later. Okay, what are algorithms? That's kind of like a picture of an algorithm there. Algorithms are very clear lists of how to solve equations. What is particle swarm optimization? Like what are we talking about here? That's just a graph of it. Particle swarm optimization is an algorithm where particles are generated in random areas, and then the particles align and move towards the average area of which most of the other particles go. And the particles get there by measuring the length between local particles near them. That's kind of how particle swarm optimization works. Why does particle swarm optimization exist? Why do we need it? Particle swarm optimization is used to solve nonlinear and multi-peak optimization problems for science and engineering. Nonlinear means random and multi-peak means incomparable, as in like you can't compare these two. Instead of like there's a huge difference. What are the use cases of particle swarm optimization? Power systems is a pretty big one, and engineering. Just these are both pretty much engineering. And that was the slideshow. Yeah. So okay, so this is pretty much a this is just a flowchart of how PSO works, particle swarm optimization. So this is when we press the start button, and PSO starting. This is just like everything starting up, and this goes to updating everything. This is just like an infinite loop until it stops. So once it starts, it goes to set particles in their random positions, and it gives them random velocities too. And now that it's done giving them velocities, now it like starts calculating. And then pretty much it just finds the global best, it just prints it, and then it goes to stop. Yeah. That's kind of how this flowchart works, and kind of how PSO works on a standpoint. So like there you go. Use it. Learn from it. Yeah. So we're about to start the programming part, but first we need to install a library for our code to work. I'm running Python 3.9, so I would suggest you upgrade to 3.9 if you're not already at Python 3.9. So you're going to open up command prompt, and then you're going to write pip install PySwarms. PySwarm, not swarms. And you press enter. I've already installed PySwarm, so my screen. So I'm going to open up. We're actually going to need two scripts for this. My first script is particleswarm.py, and I also added one more, which is particleswarm. Let me check. Particleswarm utility.py. So first we're going to be doing particleswarm.py. There was a reason why we downloaded PySwarms, and this is why. So first we're going to write import numpy as np. Basically saying if you want to use numbers in Python, like random kind of, you only need to write down np. And we're just gonna import copy, just in case. Yeah. And now we're gonna write import numpy dot random. This is actually why we got numpy there. And we're just gonna write as RND. RND. Now we're actually going to need the not yet created script. So we're going to do that. Import particle swarm utility as PSU. Nope. As PSU. PSU. Okay. Also, I forgot to mention particle swarm utility and particle swarm.py have to be in the exact same directory or like folder, because they can't access, like Python can't access like your whole PC search for something. So put these both together if you want it to run. It will not run if you don't. So I think we should actually start the coding. So we're gonna make a function real quick. And I'm gonna call it particle swarm. Particle swarm. Gonna write F. We're gonna want our bounds. We're gonna need our particles. We're gonna need C1 just as placeholders. C2. There we go. We're gonna need Vmax. You can name these whatever you want. You just have to change the things accordingly. Actually, no, I don't think you can. Just to play it safe, just keep it like this, just to not ruin it. So we're actually gonna make a print statement, which everybody's done, I'm guessing. Print placing particles and giving random velocities. There we go. And we can go down. We're gonna write D, and we're gonna put comma. We're gonna write particle We're gonna write particle, and we're gonna write P underscore POZ. Actually, really quick copy that, just so it's a lot easier. I'm gonna write best. I'm gonna write swarm best. Gonna need particle velocity. How do you spell velocity? Okay. I'm gonna put a backslash. And you're gonna need a space before it. Now we're gonna write local best. Pause. Val. Okay. Now I put another backslash. This time we go down. We're gonna make a equal sign, and then we're gonna write PSU dot initiation it won't do anything. Don't run it until you've made particle swarm utility.py 2. We're gonna need f that we reference here, and we're gonna need bounds. Then we're gonna need p that we wrote up there. This is just initializing all of the arrays. And then old swarm best. There we go. The old swarm's best. And then we put one of those, and then we do that. We put a 0. Not a no, a 0. And then all we do is we just multiply that by d. There we go. Okay. So C3 is C1 plus C2, which we referenced up there. We just created C3. Nice. So we're gonna write K equals 2. So this is just a variable. Then we write slash. We put one of those abs. And then we write 2 C3 NP dot SQRT. There we go. Okay. We do that. Actually, we're gonna have to add 2. Then we're gonna write C3 two multiplications. 2. We go there. We go one parentheses back forwards, and then we put another one parentheses, and then we write 4 times C3. There we go. There should be 4. Yep, there's 4. Okay. Yeah, this is creating the velocity swaying factor. Yeah, so now we're gonna go down 1. IT count is 1. Wait, no, 0. There we go. And then while abs, gonna write F old swarm best minus F swarm best is bigger than toll, TLL up here. There we go. This is just exiting the condition. We're gonna go down 1. We're gonna go press tab once, and we're gonna write IT count is 1. And now we're going to write if IT count is bigger than 1,000, every 1,000 iterations, we're going to create some conflict. Okay, really quick, you're going to have to add a colon right here. Then we're going to write print causing conflict. There we go. Okay. Now we're gonna write actually causing the conflict. So we're gonna write for j in range P, which we wrote up here. P, okay. Now we're gonna write, yeah, this is just pretty much an if statement. This is just iterating over the numbers of the number of particles. Particle velocity. Gonna put a square brackets. Gonna write J. And then we're going to write gonna put an equal sign, and then we're gonna write 2 of those. Gonna put a square brackets and then a parentheses. Write RND that we referenced up here. Okay. RND dot uniform. Another parentheses. Minus abs. Bounds. I'm gonna put square brackets. I. Then we're gonna put another square brackets and put 1 in it. And then we're gonna do another one. Oh, no, we're gonna put minus bounds. And then we're gonna write another I. And then we're gonna write another square brackets, 0. There we go. And then we put just really quickly, let me check something. Yeah, so we're gonna have to put another backslash. There we go. Abs, bounds, I. And we're gonna do another one, and then we're gonna put 1 in it. We're gonna write minus bounds. There we go. I'm gonna put I, 1, minus bounds once again. I know this is supposed to be I0. And then, wait, is that supposed to be? Yeah, okay. And then, yeah. And then we put 4 I in range D. And then put the square brackets there. Gotta really quick fix this because it's not working apparently. Okay. This is just adding random velocity. Yeah. And then we're gonna go all the way down. We're gonna write IT count is 0. And there we go. So there we go. There's a lot of code here. I'm going to put it in the description for you to copy and paste this part. This is just a lot of typing. I really just don't want to. It's for I in range. Yes, it iterates over each particle and it creates 2 random numbers. Yeah, and then it's just any velocity greater than Vmax. Okay, now we're gonna go all the way down. I mean, until I, and then we're gonna write particle pause particle pause now we're going to do that. We're going to write I, we're going to put a comma, and then we're going to put a colon, and Vmax. Okay, go down to PSU dot within bounds particle pause and we're gonna put square brackets, and then we're gonna put I. There we go. Okay, this is just if the particle is out of bounds, just to make sure, you know, it's like not, it hasn't escaped. And we're gonna write particle fitness equals F particle pause I. There we go. Okay, and maybe I should actually explain this. I mean, I kind of already did here, but you know, this is just creating two numbers. This is just like finding a uniform. This is just like a pretty much just saying, look at between these numbers and it just creates two random numbers between those. You can edit this to probably whatever you want. I don't think it would break anything. This is just checking if any particle is greater than Vmax. Yeah. So, I'm also going to copy another part. I'm going to put this all probably in the description. Yeah, no, I'm going to have to put this in the description. So you won't have to spend as much time searching for it. It will be in the description. Yeah, that's kind of it. Not completely done though. We're still going. Okay, we're gonna have to go down to, going to do local best PSU dot local best get particle pause val p. There we go. Okay, now that that one's done, we can go down to do our return. Here we go. Return print. This is where we're actually printing like the optimum. Swarm best. I'm gonna write backslash and to go down a line. Function at optimum I'm gonna write F swarm best. Okay. Now we can go down a bit. Now we're going to write PSU dot Rosen raw. There we go. Okay. Dimensions is 10. Dimension bounds is actually square brackets -2 to 2. I actually completely did that wrong. Gonna quickly. There we go. Okay, so we're gonna go down. Bounds equals 0 times dimensions this is just creating 5-dimensional bounds real quick. And then for I in range of dimensions, bounds I dimension bounds. This just creates a few bounds. Okay, we're almost done with this script. We still have the other script to go. So, this. Okay. I'm gonna write P equals 60. This, I don't think you should change this. There's not much point. Vmax is dimension bounds 1 minus dimension bounds 0 times 0.75. Now C1 will be 2.8. You shouldn't change that either. And also you shouldn't change this either. What I'm about to type in for C2, we're gonna write 1.3. Alright. Now what is toll? 0.0000000. Wait. 0, 0, 0. Okay, this is how many zeros. I don't think that is easy to tell what it is, but you know. It has 6. That is way too many zeros. I don't know. Count it yourself. Particle swarm F bounds P C1 C2 and Vmax, and also add some toll. There you go. Also, I didn't do that. Nice. Of course I didn't. Okay. So, that was all the code for particle swarm.py. You just gotta make the utility, which should only take a little bit. I wouldn't say that long. Okay. So, this one is also like 75 long. Things long. I don't. Yeah, 75 lines long. So let's get started here. Um. So. Yeah, we're just pretty much importing everything that we did before, only that we're adding matplotlib library.pyplot, and also we're importing time. Yay! Yeah. Okay. So we're gonna go down. Remember Brock that we wrote down here? This is Rosenbrock. I'm just going to put this all in the paste bin, so you don't have to painfully type this all out. So that's Rosenblock. And we're going to add another one. It's called Styblinksky Tang. Going to go down here. I'm going to explain what this actually does. Okay, so pretty much this is pretty much like the backbone of this. You could call this code as kind of like what you would see on the front end, and this is kind of the back end. This is just like kind of a nightmare to explain. So I don't think I'll have much explaining to do here. So, and also we're going to include another one. It's going to be called Ackley. These are all just variables here. Like half of these are variables, and then they're all just like doing a bunch of that's all the calculating. This is all the calculating. Now local best get, this is actually like, we'll find a local best. So this is just creating an empty local best list. This is just a list of all the local best particles. Finding the best particle in each neighborhood and storing it in local best that was in here somewhere. Yeah. Okay. And initiation. Yeah, initiation, we're going to also need that. These are extremely long half the time, so I'm going to put this in too. Here we go. Creating a number of, just finding dimensions, creating a position array, converting the array to a list of like stuff. Empty the array that we're talking about over here. And then we're going to empty the value array. We're going to iterate over the numbers of particles. Random coordinates within bounds. Find random coordinates. Calculating the function value, and then just at each particle. Creating random velocity values for each dimension. Pretty much just like for every dimension, it's just creating random velocity for the particles. Getting the lowest particle value, and then it's just setting them all to the best. Yeah, that's an explain of that. This is the last one here. We're gonna have to type in. Well, we're gonna have to paste in. If this is just this is just checking if it's within the bounds. If the particle is less than the lower bound, you just reset it kind of, and then if it's too high, you just reset it to the highest value. So now if we run it, it should work. And there we go. It is working as intended. Just give it like a minute. It will finish on its own. I'm pretty sure it takes exactly a minute for it to finish, and occasionally it flashes. That's the particles are too friendly right there. Yeah, this is actually swarm optimization. Like, this is what you're seeing is like pretty much AI in like 150 lines of code. So it's actually pretty nice. Yep, here we go. We're reaching the end. Yep, there we go. Okay. This is the optimum for my swarm optimization. Yeah. That was the video, guys. I'll see you on the next one. Like and subscribe. Share this too. This took a while to make. And I'll see you guys in the next video.